All right, so we've been taking a look at the normal model. We've talked about the 68, 95, 99.7% rules. We've also looked at z-scores. We're going to put those two things together today to answer some questions about the normal model, what it can actually do for us. So we're going to be looking at ACT scores today. It turns out ACT scores roughly follow a normal model with a mean of 20.8 and a standard deviation of 4.8. So the first thing I'm just going to remind you of, I'm going to draw a picture here, is what the normal model looks like. So just a quick reminder, we put the mean in the middle, and we'd consider up and down 3 standard deviations. So if I go ahead and use the standard deviation of 4.8, that means going down I get 16, 11.2, and 6.4. Could also go up, but my point here is that I just simply want to point out that 19, I don't know, that's like right here. That's not a nice, pretty location. So I can't use that 68, 95, 99.7% rule to help me figure out what percent lies below 19. So what I'm going to show you today is how we can use our z-scores and our calculators to answer this question. So I'm just going to go ahead and mark that this spot, this lovely spot right here, 19, on my picture. And I'm going to shade below that just to help me remember that I'm doing below 19. I would strongly encourage, actually I'm going to require that you draw pictures for these problems, especially to start with. You'll find it very helpful. So I know that 19 is not 1 standard deviation down. It's less than that. I don't know how many standard deviations away 19 is, but that's what z-scores actually calculate for me. Just to refresh your memory, z-score, we take our data point, we subtract the mean, and we divide by the standard deviation. So I'm going to do that here. I'm going to calculate my z-score by taking 19. That's the data point I'm interested in. I'm going to subtract the mean of 20.8. And I'm going to divide by the standard deviation that was given to us in the story problem, 4.8. Please be very careful with your calculator. Remember your order of operations. It might be helpful to even use parentheses. So if I plug that in my calculator, I get negative 0.375. By the way, in your brain, this negative should be a really good thing because we are below the mean. All right, so this tells me, wow, I'm not 1 standard deviation down. I'm negative 0.37 standard deviations away. All right, so let me go ahead and kind of identify that right here. This 19 is the same as negative 0.375 in z-scores. While we're talking about z-scores, notice I started shading right here at negative 0.375, and my shading goes forever in the negative direction. So I need kind of a stopping place for my calculator, because we know that this picture goes forever, but my calculator doesn't really handle the concept of infinity. So I'm just going to use a really, really large number, really big number, like 99. Yeah, your book suggests 99. Because we're in the negative direction, I'll go ahead and call that negative 99. So I'm going to use these two numbers as kind of boundaries for my calculator. And I'm just going to say, hey, Mr. Calculator, what percent is between these boundaries? So to do that, let's go ahead and pull out our calculator. I'm going to go to a special place in the calculator that knows all about the normal model. I get there by pushing the second button and then this bars button. You'll see there's a distribution on top. That's this one right here. So you'll notice again, the distribution on top takes us to the distribution menu. We will never use number 1. So in your brain, just be thinking normal CDF. Number 2 will be our choice. I'm going to go ahead and push enter there. Then my calculator needs to know a couple of things. Looking at my picture from left to right, what have I shaded in? Well, remember, the left went forever, but I can't tell my calculator forever, so I'm going to use negative 99. And then I use a comma to indicate I'm going to give it the other endpoint. I've shaded until I get to 19, but my calculator doesn't know we're talking about ACT scores, so I've got to use the z-score numbers. So that's my negative 0.375. And I'll close my parenthesis. And then all I have to do is push enter, and it gives me the percentage. It's amazing. Miracle. So I have 0.35, oh, if I round that off, 0.354, that's 35.4%. So I'm going to go ahead and write that down. What percent of students score below a 19? Well, it was 35.4% of students. It's a pretty good chunk. One way to show your answer is to just, my favorite, draw an arrow coming out of the picture. Go ahead and write your answer right there as well. That's a great way to kind of show what you're doing. 35.4%, that's our answer. Let's go ahead and take a look at another problem like this. We'll go to the next one. All right, same setup, but this time I want to know what percent of students score above a 30 on their ACT. So this time I'm going to go the other way, an above problem. So I'm going to go ahead and draw my picture. Now, you're going to want to draw 1, 2, 3 standard deviations all the time, because I trained you. Save yourself some time and some agony and skip that part. So here's 20.8. I'm just going to draw in 30, because that's the number I'm interested in. I don't know where it is. It's just a sketch, so I just guess. There's 30. It looks fine. And since we're doing above 30 this time, I'm going to color in above. Now again, 30, I don't know how far away that is, so I'm going to calculate a z-score. Z-scores, we take our data point, we subtract the mean, and we divide by the standard deviation. Very carefully inputting that into our calculator, I get 1.92. Wow, so a 30 is almost 2 standard deviations above average, almost. All right, so remembering that I'm starting here on the left, I can't put 30 into my calculator. My calculator doesn't do ACTs. It only does z-scores. So this place that I started shading at the left, see, here's my shade. This is at the left of the shade, 1.92. And then I keep shading forever. So if I want to give it like a place to end on the right, I can't really say forever. So instead I use, consider this 99. Okay, so these in red are the 2 numbers I'm going to put into my calculator, from left to right. All right, so here we go. Back to my calculator. It's second vars, number 2. And I go from left to right. I had a 1.92. Comma's just above the 7, 99, because I'm shading forever in the positive direction. And here we go. I got 0.027. Wow, that's 2.7%. That is a small number. My answer, 2.7%. I'll really make this stand out with my answer here in green. Again, you can do a little arrow coming flying out of your shaded area. 2.7%. That's the answer. That's a really small percent. But that makes sense to me because 30 is a really high score. So I would assume that it would be a small percent of students that score above such a high number. All right, for our last example, let's go ahead and see what happens when we do between 2 scores. I'm going to start the same way. I always draw a picture. I put the mean in the middle. And now I have 2 numbers I'm interested in. So I'm going to put those both on my picture. 20, that's like really close here. 20 and 25. All right, and again, I'm interested in what is between those numbers. So I'm shading between. Wow, well now that I have 2 numbers, as you might expect, I'm going to need 2 z-scores. So I'm going to get a z-score for this value of 20. Remember, to get a z-score, we take our data point, we subtract the mean, and we divide by the standard deviation. I'm going to do the same thing with 25. To get my z-score, I'm going to take my data point, subtract the mean, divide by the standard deviation. Now, just take a moment, reflect. For 20, I think I should get a negative z-score because I am below average. For this 25, notice I'm above average. I should be getting a positive z-score. And it turns out that's what happens. My z-score for 20 is negative 0.17. My z-score for 25 comes out to be positive 0.875. You'll notice sometimes I rounded 2 decimal places, sometimes 3. Pick whichever one makes you happy. So again, if I'm considering in my calculator needs to know z-scores. I can't say I'm looking between 20 and 25. I'm going to get some sort of crazy answer. So instead, I'm going to give my calculator z-scores. Now notice I have this shaded area in the middle. Shaded. On the left, I've got a negative 0.17. And on the right of my shading, I have a 0.875. These are the two numbers I'm going to put into my calculator. So I go to second bars, takes me to the distribution menu. I choose option number 2, normal CDF. Negative 0.17, that's on the left of my picture, comma, 0.875, that's to the right of my picture. And this will give me my percent. Wow, 37.7%. Let's write that in. Here's my answer. 37.7%. Very interesting. 37%, almost 40% of students score between a 20 and a 25 on their ACT. All right, and those are our examples of how we use the normal model to calculate some pretty specific percentage questions.